Please welcome to the stage Global Head of Risk and Investment Analytics Products at Bloomberg, Zane Van Dusen.
Hey everyone, it's really great to see you today. As mentioned, my name is Zane Van Dusen and I manage what's called Risk and Investment Analytics Products at Bloomberg. Essentially, we take a lot of the really great data that we have there and apply advanced techniques like machine learning, AI on top of it to do cool things. We've been doing that for a while and we've learned a lot of tips and tricks along the way, and that's what I want to talk about today. How it is to manage AI products or these products that have a mind of their own. Not surprisingly, the reason why I'm doing this and probably why I was invited here is that we're in a bit of an AI boom. AI really became a lot more accessible in 2022 with the launch of ChatGPT, and accessible is the word I like to use because the data is available, the tech's available, and it's a lot easier to implement and deploy this stuff. And it's kind of amazing in the past 2 years, the stuff that can be done, right? You can go to ChatGPT like I did here, and you can say, write a user story for ChatGPT for a new feature. It's like mind-boggling that that can happen. Now, everything in the AI machine learning space is all about the underlying data. So not surprisingly, you know, the data's pretty good. You can get a pretty good user story off the back of that. I then said, can you write the code for this? Once again, did a pretty good job, not surprisingly. And then I said, let's go to the next phase of the project. Tell me why this project is 3 months delayed. And it's like Hemingway, like the most beautiful prose I got out of this, because the data is really strong. They're really good at justifying why products are delayed, and hence why, you know, the data is a central element that I'm going to be talking about today. Not surprisingly, because of this boom, a lot of new products are going to start incorporating AI, right? And lots of companies are rushing to AI because of a fear of missing out. And they're about to learn a lot of lessons. Like, I look at this and I think about like my siblings, my friends, when I have kids and they're pregnant and they're talking about like all the great things that they're going to do and how they're going to like talk out everything with their kids. And it's not going to work that way, right? Like the 5th time they throw the baby food on the floor, you're not going to talk it out anymore, right? And so these tips, hopefully from being in the trenches with AI and going through all the dirty work, will hopefully help you have an easier first time working on AI products because we've gone through this before, and it's things I wish I had learned along the way. So what I'm going to talk about is I'll talk a little bit about my AI journey at Bloomberg and before and how I got here. We'll talk about some of the types of problems that AI is really good at solving, because I think the key thing is to understand when to use it and when not to use it. It is not a silver bullet. Then I'll give you some key skills and tips that I think are super important when you are working on an AI product. And then I'll quickly touch on how you potentially build a team that's really well suited towards building AI and machine learning products. So, all right, let's talk about my AI journey. So I started as an engineer. I did computer science in my undergrad, and I went to an investment bank and I programmed for 5 years. It was in the midst of the financial crisis, so nothing like a crisis forces you to go true agile. I sat with the business and I started to turn to the business side of things. And that's where I became a traditional product manager. I knew my product inside and out, everything it did, every calculation. I totally got it. It was under my control. And around that time, machine learning started to be very sexy in the techie circles. And so I started dabbling with it around the time I had my first kid, who you will meet later in this presentation. And at this point, I thought this was going to really prepare me well for my next role. I really wanted to do something in the machine learning space. Bloomberg gave me an offer to do this, and they threw me in the deep end. But what I was surprised to learn was that having a kid was probably way more influential and more telling to me about how to manage a machine learning product, a product with a mind of its own. And I'll talk about that in a little bit. I had my second kid shortly after, and then with all these lessons learned, with all this experience of actually working on the products, we started actually winning lots of awards and getting this high adoption of these AI products after a lot of hard work. And probably my new favorite accolade in the AI space is that yesterday I got to interview David Ferrucci, who led the IBM Watson program, the program that beat Ken Jennings in Jeopardy. And I did that as a hologram. I got to do that for Bloomberg, and I think like that's an amazing thing why we even did that, but like it's the best AI credential I think you can have. So that's a little bit about me. I will quickly throw you into what our product is, what's kind of our most popular AI product that I work on. And I won't go too much into it, but this is my AI baby. This is our liquidity solution. If you're not a finance person, quick, simple explanation. Liquidity is how easy it is to convert something to cash or to sell it, right? If I own stocks, if I own bonds, if I own real estate, how quickly can I sell that, or how much of a loss am I going to take trying to sell this quickly? As you can imagine, that is a super important concept in finance, right? That's literally the backbone of like everything we do here, yet there's not a lot of consistency in the industry. We like to do this poll up here where we say, all right, how do you think liquidity has changed in the past 6 months? And usually every time we do this at events, it's about evenly split, like 33%, 33%, 33%, right? People can't really agree, is liquidity better, is it worse, unless there's a crisis. So there's a need there where we said, all right, maybe we can do this quantitatively. Maybe there's some data that we can use to standardize this, give people a better sense of what liquidity is. And that's where we said, maybe AI is the opportunity here, right? And this was back in 2017 or so. And we said, all right, can we build an AI model that takes all this trade data, all this information, and estimates this relationship between volume, cost, and time, and generates very fancy surfaces like this? So we can say, look, you want to sell X amount of this in 1 day, here's how much it's going to cost you. And we can do this for most financial instruments, which is pretty powerful because if you're not familiar, in the bond market, maybe 20% of bonds trade in a given day. So not a lot of actual trading activity and a lot of need for this estimation. So there's my crash course on liquidity and finance. But there's many other things you can do with it, and there's a lot of different things we've done at Bloomberg. And I find this to be a really useful kind of explanation of where I think AI products are very powerful. So the first type, which is aligned to the one I showed you before, is this concept of prediction and estimation, right? When data is incomplete or it's missing, AI can really help you out because it's really good at figuring out those complex relationships between important factors and the target behavior, right? It can look at all the data points and say, when I see X, Y should happen. And it can do that very consistently, unlike your mind, which will have various biases. Good examples of this are like weather forecasting, right? We look at things like barometric pressure, wind speeds, things like that, and we can try to predict will it rain over the weekend. On the Bloomberg side, one thing we do is we use this to predict greenhouse gas emissions of companies. As you can imagine, more and more as we're getting more environmentally conscious, people care about the greenhouse gas emissions of the companies they invest in, yet most companies don't report this. But if we look at the data that's available, we can figure out the complex relationships like how many people work there, the size of the company, the sector, to come up with a pretty good estimate. The next type is classification and tagging. This is really useful when you need to create a set of categories or tags to figure out where new data points belong. AI is really good at efficiently assigning categories and tags with high accuracy and consistency. Things like spam detection come to mind, right? Looking at an email, determining is it valid from your friend in Nigeria or is it a Nigerian prince? Or on the Bloomberg side, classifying controversial news articles, right? Once again, we care about bad news about a company, but not all bad news is created equally. If a company is dumping toxic waste into a lake, that's bad in one way. If the CEO is committing major fraud, that's bad in a different way. And being able to quickly identify, based on the attributes of the news article, what type of bad news this is, or if it's good or bad, is super important. The last one I have is information retrieval. This is when you need to extract information from like really big unstructured data sets, because AI is really good at scanning through that data and finding the relevant information and summarizing it for you. Things like search engines come to mind. One way we use this at Bloomberg is for supply chain, right? You want to understand who are the suppliers and customers of a company, not something that's widely reported, but you can look at press releases, you can look at news articles, and you can scrape from all that data who are the people supplying a company, who are the customers, and just important information that you can scrape all together. Now, I did this presentation internally, and at some point right here, a lot of people said, wait, what about generative AI? You skipped that here, and I get it. Yes, it's very important, but I feel like, and I think there's a bit of a consensus here, that generative AI is still finding like its true calling, right? It's an amazing technology. I don't think we found like the killer use case for it just yet, but here's my take of like where it's going to be very useful, with the caveat that I'm sure this will change over the next 9 to 12 months, maybe a couple years, right? Gen AI is very good at generating new content based on a large body of existing other content, right? It can quickly summarize complex topics, can propose an initial draft that you can use, and that's things like ChatGPT or these smaller language models that other companies do, like Bloomberg GPT that we use to, let's say, summarize earnings calls to quickly get information that you need. As I said, I think this will evolve over time. So now that you understand what types of problems we can solve with AI, how do we approach these products? And this is where a lot of my learnings as a parent came in, that unlike a traditional product, like the products I used to own when I was back at the bank, you do not have full control over an AI product, and that is by design, right? They have a mind of their own, and that is okay. It is going to do things you didn't expect, and you need to take a deep breath and accept that that's going to happen, because that's why you're using AI, right? If you're trying to build something and it does exactly what you want, then AI is not the solution. If you want to do something where the student eventually becomes the teacher, this is where AI becomes very powerful. So you need to think of yourself more as like a coach, a mentor, or a parent of this product, right? You are giving it the necessary information it needs to make the right decision when you're not around. This can be a new skill for you, right? It's hard like going in there and not having that full control of knowing every single thing, every single quirk of your product. So what does it mean? For you, it's a lot less about how the product works and more about what it is trained on, right? What is the data it needs? And this is where you need to come in with a lot more domain knowledge about the data that's out there, especially because the quants and data science you work with, they are special people. They are very mathematical, and they explain everything mathematically, and you need to kind of pull everyone back and say, all right, well, what is the intuitive understanding of this problem? Because at a certain point, someone's going to ask why, and throwing a bunch of numbers at them is not going to help. So think about things like, how would someone do this without AI, right? If someone's telling you a problem where they have a lot of finger in the air subjective judgment, AI might be a good solution here, right? Because it's very much designed to capture that kind of human behavior and human thought process. But try to figure out how they would do it so you can benchmark that later, right? What data is important versus what data is not important, right? You want to feed it information that's very valuable, because if you give it noise, it will learn from the noise and will go from there, right? If you're trying to teach your kid geography, you don't want to send them flat Earth websites. You want to send them proper websites about how the Earth works and things like that. This data is usually pretty messy, and you have to normalize it. Don't forget the obvious stuff. In the finance world, like if you got like things in dollar values in Japanese yen, those are very different currencies. Like make sure that you normalize everything so that it's very easy, so that there's no assumptions that you're making that the machine would have to learn on its own. And then figure out where you need to be good versus where we can be okay. This one's especially important because a lot of what AI gives you is the ability to do things at scale. And the reality is you cannot do everything amazingly, right? So figure out where are the places where I need to be super on and where we need to test it thoroughly, and where are the places it's okay to like be okay and maybe have an odd answer here or there and learn over time. Those are super important things for us to think as we build these AI models, because you cannot test every single scenario, right? ChatGPT, you can literally give it anything. You can't test it for everything. Then when you start working on a product, you have to make sure that you're keeping everyone honest and asking all the questions, right? You're going to be in a room with a lot of smart people, and you need to be the dumbest person in the room, because you have to ask every question to be that proxy for the end user, and then be able to translate that into a story focusing on the why versus the how, right? We don't want mathematical answers here. You need to be able to explain what you're doing to your parents, your kids, your boss's boss, your end user, and that can be really challenging. This is an example of an actual graph that one of my quants brought to me and said, Zane, we just did a test on your liquidity model, and here are the results. What do you think? This is like, so let's do an exercise, right? Let's get comfortable asking dumb questions. Look at this chart. Ask me a dumb question. We'll figure out what this chart means.
What's on the axis?
This is my favorite question. I don't know what data scientists learn in school, but someone's telling them don't label your axes, which is crazy, right? So the y-axis, right, is the amount of volume that we observed in the market, and the x-axis is the amount of volume that we predicted could have been traded. What's the measurement? Yeah, volume is the measurement here, and it's very small. Another great axes trick that they do here. It's like that's I-e to the 7. That's in millions, because most people don't use scientific notation except for quants. All right, what's next? What? What do the colors mean? They make these beautiful charts, right? And I always give them names like food. We call this the avocado chart. So red is the amount of observations, yellow a little less, and so red is like lots of observations, yellow is a little less, purple very sparse, white no observations. So we're saying a lot of observations in the center there. That's where we want to be good, right? Because that's where most of the data is happening. Maybe one or two more questions. Why is there so much white? Yeah, well, as I mentioned, right, the bond market is very sparse, especially when you look at large trading volumes. So most trading volumes happen in that like $1 million range. You don't see a lot of $4, $5, $10 million trades for a lot of bonds. That is an excellent question, right? What would good look like? Always challenge them, because they will often give you the answer to say, well, a good chart, a good success, would be a 45-degree line, because these dots in the middle here are representing the average when we're looking at each of these different grids on the box here of where our prediction was versus observed. So a 45-degree angle would mean we predicted things pretty much perfectly, but in terms of where we need to be good, we need to be really good in this red spot. In the white and purples, we can be a little messy because, you know what? There's not much data out there. So hopefully it's a good exercise, right? You don't even have to have the expertise, but asking the simple, basic questions is super important because you will see lots of beautiful charts. I think you also have to get really friendly with the machine, right? AI algorithms get a bad rap. They're called black boxes. I actually fundamentally disagree with this. I just think the explanations are not satisfying, right? You can actually explain how most of them work, but the explanation is not really appealing to most people. You need to think of yourself as more of a therapist than a neurologist. So I'll give you an example, right? If I go to I went to a party with my friend Tom. He's having a good time. My other friend was talking to him. She came over and said, Tom was really great, but at a certain point, he got really dark and just left. What the hell happened? And I said, well, I could have said this, right? I could have said to the neurologist, well, he's got a bunch of neuroreceptors and a bunch of chemicals went there, and this one collided in this one, and then he had a bad reaction and he left. It's not a satisfying answer. The real answer is, did you mention Vancouver because that's where his ex-wife lives and he got really upset around that, right? It's the real answer. You want to have that kind of relationship with your product. So once again, think about someone that you know, right? You know really well. You know why they do things, how they do things. How did you get to know them? How did you get to know them really well like that? Talking, yeah, having lots of conversations, right? Back and forth, you give a little, they give a little, you learn something. Anything else? Time, yeah, you have to spend time, right? You can't just jump into it and think, all right, I know how this works. It's going to take months to really understand how these things tick. I love stressful situations, right? Like how someone reacts in a weird scenario tells you a lot. And I'm sure that when they were developing ChatGPT, Sam Altman was like, let's give it some really weird stuff and see what happens. Because then you're prepared, right? Then you're not surprised by when those weird answers come out. Any other good ones? Asking questions, yeah, right. Learning about how did it come to that decision, right? The how is very important, especially when we're trying to tell a story. I'm surprised no one's mentioned it. It usually comes up. Drinking together is a good one. The machine cannot drink, but like getting a little weird with it, right? Like when I first started working on our liquidity product, I would like stay up and like I'd get a little weird myself, and I'd be like, what happens if I like change everything like in a completely ridiculous way? You want to figure out the edge cases because then you are prepared when someone else does that. So what am I saying, right? You want to understand how it behaves, not how it works. You want to look at the key inputs, right? I want to understand that it's like the divorce, not the neurochemicals that's causing this reaction. What is it sensitive to, right? What are the key parameters that really make a change there? And what tends to change over time? This also applies into troubleshooting, right? You want to think about how the machine works. You want to look into different things. This chart up here I forgot to mention is another good example of like, so this is called SHAP analysis, and quants and data scientists love to say like, SHAP analysis provides explainability to AI models. And they're like, look, here's a model for predicting the taste of wine. Here you go. This is a Rorschach test, right? Like it doesn't mean anything. It's still a weird picture, and you have to ask lots of questions to understand it. There's more storytelling that you need to do. On the troubleshooting angle, it's really important because your models will do weird things, and you want to understand why, right? You don't want to just instantly jump to conclusions and then start saying, well, I figured it out. This thing's totally broken. Maybe it came to a logical conclusion and we didn't give it the right data. That's a more appropriate answer. To give you a real-world example of this, I will introduce you to my son. He was on a show called Recess Therapy, and this is how he does math. If you haven't watched Recess Therapy, it's really amazing TikTok, Instagram series.
17 plus 7.
24, I took away the 7 from 17 and added on the 7 to make 14. And then the two 10s, I put them together to 20. And then there was a leftover 4, which makes it 24.
Can I tell you something? Math is really hard for a lot of people.
What?
Are you surprised?
So surprised. In fact, when I was in kindergarten, every single math lesson, I was like, I already know this stuff. I already know this stuff. I already know this stuff.
8 plus 7, go.
15.
Yes!
2 8 are 16, and 1 less than 16 is 15.
So, he's obviously very good at math, but if you're like me, older than me, similar generation, you probably do not do math this way. And the reality is, sometimes he gets it wrong, right? Sometimes he says 17 plus 17 is 24. Instantly, I bet a lot of you are saying, oh, he forgot to carry the 1. If I try to explain carrying the 1 to him, it is completely meaningless. I essentially have to retrain his whole model that works really well for him. And this applies to AI models, right? It's probably too expensive to retrain a model if it's got something that's working for it, right? Try to figure out how does it think. I have to think about, he's using this interesting doubling technique, right? Think about that doubling technique and where did he forget the 10? Speak in his language. I will get the results I want much easier than trying to completely learn things from scratch and essentially retraining him or retraining the model. Another important one is setting expectations up front. This is all kind of standard product stuff, right? You want to make sure where's your focus, what needs to change and how, what shouldn't change when you implement it, and how long do you need to measure stability. Stability is a really important one because these models are a little weird, right? You need to make sure that it actually can run on an ongoing basis, producing consistent results. If every time you go to it, it gives you a different answer, that's probably not super satisfying. But maybe it's okay to change over time, right? Because maybe things change. Another important requirement to consider, though, is explainability. Right? This is a chart here explaining different types of AI models and how they compare from explainability or interpretability versus accuracy. So you can see rules-based learning, very easy to understand, it's rules, but not a lot of accuracy. Deep learning, a lot of accuracy, very hard to explain. The y-axis there is super important. On our liquidity project, the low and high, the difference is like 60% to like 80% accuracy. We've worked on other projects where the difference between these is like 60 and 63% accuracy. It's not really worth it if you're not getting 3% more accuracy for a whole lot less explainability and accusations that you're running a black box. So hopefully those tips are useful. The last tip I have is building your team, right? Hopefully you've got the message by now, data is everything here. And so really you want to look for data, right? People who are good at data analysis and troubleshooting, people who are good at database design, data wrangling, getting the data all nice and tidy, and documentation of your data, because the data is the foundation of the AI models. When you work on any AI product, probably 20% or less of the job is the actual fun AI machine learning stuff, TensorFlow, gradient boosting, blah, 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 blah. Most of it is like going through and getting dirty with the data. And being able to have people who are really good at this will save you a lot of time in the long run and save you a lot of heartache, right? Because if you can have that fundamental conversation of, well, we saw this data point, and this is why it behaved this way, as opposed to, well, embedding feature number 5 said 3.72, and that's why now the number has changed from 10 to 3. It's a lot more powerful. In general, you probably don't need super sophisticated quant and AI expertise unless you're like in a very specialized field like physics, a little bit of finance, but even then, the data is way more important. I would ask all your interview questions about how they manage data and how they think about it. So, in the last couple minutes, my key takeaways here. When you are working on an AI product, you want to take this mentor, coach, parent mindset, right? You no longer have full control. You want to give it the information it needs so it can go out into the world and thrive and someday be smarter than you. You want to figure out where are problems where AI is great, where it's not super useful. It is not something we need to use for everything. It's not worth it. Use your resources wisely. Get deep with the data. Don't worry about the model so much. The models all work in kind of similar ways. They work like your brain, right? They try to come up with intuitive assumptions about how the world works. Build stories off of it, right? Learn how to tell stories about how your product behaves, because the right answer is not usually the one that's going to make your clients happy, make any of your stakeholders happy. Empathize with the machine, right? Try to figure out how it works. Don't just assume because you figured this out, this is how it should do it. It might have something that works for it, and that's totally fine. Work with that. That's going to save you a lot of time in the long run. And then build your team of data geeks. You want to make sure you have people who are great with data, yourself, your quants, your engineers. If they all understand the data, you have a much more powerful conversation and a much happier time working on these types of products. So hope you all found this useful. Happy to chat more during the break. But with that, I will sign off. Thanks, everyone.